Hello everyone. Today we will be just building the mini query language in C from scratch, no dependencies, no libraries, and this is going to be the kite we're going to use for databases and search engine. And the core idea is it's structured and it's powered by an abstract syntax tree, and by the end you're going to be understanding how a lexer works and also how to be able to build a recursive descent parser, and you can work through the tree and evaluate it. So let's just start into it. So the idea is you're going to have a bunch of expressions, or more generalized is an abstract syntax tree is a tree representation of a structure of an expression. An expression can be, for example, p equals 1. This expression is going to be evaluated, and the abstract is going to extract meaningful tokens from this entire thing. Where in raw parser trees, where everything, including parentheses and any other comma token, are going to be into the tree, abstract syntax tree strips all of those and it puts the meaningful parts away. So we're going to try to make this basically it takes p is going to be an identifier, equal sign is going to be an operation, which is eq, or we can call it an assignment, and 1 is going to be a number. So that is the entire idea. So the AST is going to generate, okay, we're going to have an assignment operation from p to 1. That is basically what an abstract syntax tree is going to do. And when we have more complex operations, it's going to do the exact same thing. So the idea is this. So the entire expression that we are going to be parsing for today is going to be as follows. We're going to have p equals 20 and s, not s, equals 1. So the idea is this. We're going to try to parse this and just make a meaningful query language out of this entirety. So the exclamation mark is going to be not operation, and is going to be an end operation. Equal sign is going to be an assignment. P and S are going to be identifier, and these are numbers. So we could obviously get started. So I'm going to just open up my editor, and you can follow along if you want to. So let's just make mini query directory, and it's an empty directory, so let's just get the main idea out of the way. So the first thing we want to do is just get that specific string and just make a meaningful tree out of it. So the way we're going to do this is we're going to obviously include standard IO, and we're going to obviously return 0, and our main function takes nothing. So now let's just quickly save that expression, and we can call it like something p equals 20 and s, we can add some white spaces, it doesn't matter, and exclamation mark s equals 1. So this is the expression. So the first thing we have to do is just build a lexer. So a lexer is going to have is going to take that entire string and parsing it into a meaningful token. So first let's try to identify the amount of tokens that we have. So let's quickly make an enum for this token kind. Right, so what type of tokens we have? We have an identifier, obviously. We have a number. We have symbols, right? And these symbols can be and or ampersand per se. Ampersand, because and is the operation. And we can call it exclamation. And equal. Usually I like to keep things nicer, so we're gonna have a count. So if we would, the reason the count exists is if we decide to extend the token list, we're gonna static assert the count every time. So we could go through every file and easily modify it. So that's the entirety of the idea. So we have all the token list. So now what we want to do is just generate name from this entirety of the token. So we're going to have a function that accepts the kind and gives us a const char pointer or a string. So let's quickly just do the following. I want to just use a quick little Emacs magic with multiple cursors. I don't know what went wrong. Okay, so for now, let's just quickly print this. And here is going to be the thing that we're going to do. Default case and case count and default case. They're going to be basically unreachable. So let's quickly basically do the following. fprint std error and unreachable. And here, one thing we could do, static assert count equals. So 0, 0, 1, 2, 3, 4, 5, 6. So this is going to basically be at 5. This is 0, 1, 2, 3, 4, 5, 6, 6. 0, 1, 2, 3, 4, 5. Exactly. So this is going to be 5. And then we can just do the following. Count exceeded. So we have this. So then what we are going to do is we should be returning these, but for the sake of what we're doing right now, we're just going to quickly return whatever they are. So we have all of the char names defined. So then what we're going to have to do is just construct a simple token so that we could extract that. So let's do the following, which is going to be super easy. We're going to token kind. We're going to have a kind, and we can just do the following. We're going to have a kind, and we just need name. one thing I like to do is just have my own string implementation for this, so I can just have a much nicer time. But for now, that's too much work, and doing a lot of conversion is not fun, so let's just do the following. Const char pointer name, and we can just define the position of that specific token. AST position, like so. And this is just gonna be token underscore t. Yeah, I hope I'm making sense, and we're gonna obviously then separate it into its own mini little file. So now what we are just going to do is just create the lexer. The lexer is basically the source which I can just do the following, lexer.t. We can just do const char pointer name, and we can just have a size t of position. And after this, everything is gonna come to an end. So now let's quickly just construct a simple lexer. So we obviously we should probably be returning all of these actually. Return yes. Yep. So we're gonna simply do that, and we're gonna peek what the current lexer's character is. So we're gonna do char lexer peek. It's gonna accept the lexer underscore t via pointer, so we can just call it L. So what is the lexer underscore t? The lexer underscore t is really easy. We have to take the size of the string and subtract the position basically. So it's gonna be it's really simple, but we're gonna do the following. We have a lexer position, then we're gonna subtract the size of the string. So, and this is where I would have loved if I made a string array, because that was stupid, but at the same time it's gonna be fine. We're gonna strlen of that specific l dot src, and instead of name I should be calling this src. And after this, what we're gonna do is, if it is in fact less than, and this is not subtraction but rather less than this entire thing, we're gonna take this entire source and we're just gonna subtract, we're gonna get the position like this. Otherwise we're just gonna get a 0, and that's basically it. Then we have advance the lexer, which is almost literally the exact same thing, except it just peaks by the amount of characters that we're gonna move. So it's gonna be basically this. It's not even anything special. This is just position plus 1. Oh no, not position plus 1, it's position plus plus. So then after we constructed this, we should also probably call it like advance. Then we're gonna have an advance n, which is basically gonna be plus n. It's not an advance n, but rather a peak n, to see at the peak of that specific character. And it's gonna be literally the exact same thing as this one, except this is just going to be plus n. Here we're gonna accept a size t of n, and we're just gonna have plus n. That's it. We got all of the following things. And so now we're just gonna skip all of the white spaces, and in C, if you just visit up is white space, I think, is a function called or is space. Yeah, it's called is space. So it is in C types, and we're gonna just go there. So let's quickly just make a void skip white space, and this is gonna take the lexer via pointer L, and this is just gonna do the following. While lexer is the position is always less than. This is kind of getting a bit annoying, so attaching this would have been really nice directly inside of it, but this is as far as what we can do. And if it is less, and obviously is space of L dash src, but not technically, because L dash src is the entirety of the space. What we want to do is cast it to unsigned char, and we're gonna just peek the lexer at that specific place. And yeah, if it is that, we just simply increment we just do lexer advance for L, and yeah, that's it. So we just quickly advance, and we're gonna just iterate through the next token. So this is where creating the most important token is gonna come in handy. So let's quickly do token underscore t, and we're just gonna call it next token. We're gonna accept the lexer via pointer of L, and this is how we're gonna extract the most important position. First, we're gonna skip white space, and after we skip the white spaces, we're just gonna check if L is the position is less than this entire thing. We are just gonna assign an arbitrary p, and we're just going to quickly return. So we can immediately do that. We're gonna return the token t, and here we're gonna do what did we call it here? It's a kind. That kind equal to, it's gonna be, we don't have an end of file right now, so we should define that. So let's do EOF. It's equal is gonna be EOF, and one thing I like to do is align reg expression. Yeah, this makes it the code a little bit nicer. So the kind is just gonna be the end of the file. It's not technically end of file, but end of string, but that's what we're gonna call it. And the position is just going to be L as a position. That's it. Then we're gonna accept the next character, which we're gonna just peek into. And if it is this specific character, and now we just basically are gonna do pattern matching, and the easiest way we could do this is with a bunch of ifs, and it's easily copy pastable, and I think that's gonna be easy. If c equals to, so for now, what characters do we have? We have equal sign, so we can check if we are equal sign. We can just immediately just store it in a temporary position, which I can call just L pulse. The reason I do this is because we're gonna advance, and obviously do not forget this to put this in its own scope. and we're just gonna Lexer advance this entirely as a Lexer. Then we are just going to quickly return this entire token, by the way, which is equal, and the position is just gonna be P. That's it. Now we're gonna duplicate this, change equal sign to not. Yes. And we're gonna quit. So if it is basically not, we could basically like close this for a while. And that's it. If it is that, we're gonna do the exact same thing, but this one is just gonna be exclamation. I think I'm gonna call it too late. Exclamation. It's a bit of a long name. Then we're gonna have ampersand. We're just gonna check if it is an ampersand. These are the three things that we're gonna bother for now because we're trying to build this as fast as we possibly can. Then we're just gonna check if our character is an is digit. So we're gonna check is digit, and we're gonna do the exact same thing we did, unsigned char of that specific C. If it is an is digit, we're just gonna save the position. So I'll just mute myself so that this section of the audio is just gonna be me typing. So I hope you guys follow along, and if there is anything informative, I'll just tell you. So basically we're done with this. So all I just did is, if we have a character equal sign, exclamation mark, or an ampersand, we're just gonna simply advance and just create that specific kind. If it is going to be a character, which is a number, we're gonna just check up until its number, advance elixir, and when it reaches the end, just call that kind. If it is a character, we're just trying to make a simple identifier, so the identifier is gonna be basically it's the source plus the position minus the elixir position, and that is basically the entirety of this thing. So now what we're just gonna make is a recursive descent parser so that we can just continue with everything, and once we make that, everything will make sense. So we could, if we could add a simple like print token to see what we got so far. So the token is just gonna take token t token. We can take it with a regular printing, which I think it should be fine. So it should be really easy. So it's if basically it's if the token, basically the token name, this is basically str len of that name, is greater than 0, we're just going to be printing the token name. Or we don't even technically need to, because we can just easily just do the following: print f %sign s slash n, and this is just gonna be token kind to name, and we're gonna accept token dot kind. That's basically what we want. So let's quickly construct the elixir. Elixir L equals to the following: dot src equals expression, obviously, expr. To make things easier, I like to inline that, and the position, obviously 0, because we're starting from nowhere. That's it, and we have that. So now what we are simply going to do is just go through the entirety of the token list. So let's do that. So basically, while we can just construct token tk. It's basically that, and this is going to be, we have that, we have the token, we have the position of the token. So I will have to basically iterate up until the elixir reached the end of the file. So it's one thing we could do is just 0 initialize this thing, and while tk dot kind is not equals to t or end of file, we will just do print token, and we're just gonna pass in the elixir, but we can pass it as a reference like this. Yeah. So up until it's not a token, we're just gonna basically iterate. So let's create a simple like build.sh script, so that'll help us build the entirety of the project. And this is just to enable tracing. So we're gonna be compiling with gcc -o main.c, and let's enable all of the warning, and std equals C23 because we're using static assert. And also debug information if we ever make a mistake to make this easily compilable. And here we're just gonna make this executable. So let's TEOF. Oh, EOF is defined. So one thing I have to probably do is query replace EOF with TEOF. Yeah, that is that. Did I not save this? Okay. I'm pretty sure. Okay. All right. Static assert here. We're just gonna quickly std lib. Static assertion failed. 1 2 0 1 2 3 4 5 6. Yeah, because we added TOF. So now we're gonna have to do that. In strlen, it's obviously in string.h. This is lexer underscore t. Is digit unsigned. Oh, missing parentheses. I think I basically messed up this entire thing. Is digit. Yeah. Is alpha. The position is just gonna be L dash pose. This has to be lexer underscore t. It takes lexer via pointer, but print token takes the token kind. So what we are gonna do is next token, take it like this, and yeah, basically that's it. So we're gonna compile and it's going indefinitely. I wonder why. We can get this like from a random garbage value. It's still behaving the same. Okay, so what did we do wrong? So this is gonna be time to whoop out the debugger. Alright, we're gonna quickly run this. We're gonna go to the next expression. Perfect. Go next. Okay. Next, S. We skip the white space of the lexer, which is completely fine. Oh, I think I made some rookie beginner mistake. Because by default, obviously the position is going to be 0, but what about the size of the string? So I think I reversed it around when we're trying to do basically this of next token. Yeah, I think I reversed it. Yeah, it's reversed. Okay. The debugger is good. Okay. Here, what we're gonna do is just make it equal sign, and that's basically it. And also, it should be greater than equal to. So we're gonna do that, and we're almost there, almost. So we got that, and I would have expected it to end. Why did it not end? Okay. This is really questionable. Let's recompile yet again. Okay. Unreachable, and we did a token count where it should be token unknown. Okay. With unknown, like this. Unknown. Or we could keep it as count if it is not t in the file, and the kind is not count. I mean, count is a very wrong assumption. We should properly be calling it that, and let's quickly do that. And it's still, okay, you know what, I think this is kind of ludicrous because it's gonna obviously get here, so let's do the following. Unknown. Unknown. We're gonna have that, and we're almost there for this. TUF. And we're gonna quickly just add unknown here as well. And this is just gonna be 7. And theoretically, it's, why is it not stopping? This is really weird. Because that's the only thing that is missing. Why would it not even stop? Why would it not stop? By the way, this should be just a null terminator, just to showcase that it obviously ended. Okay, let's recompile one more time. Okay. We're gonna just quit that. And we're gonna try to see why it doesn't stop, because I would assume that it would. We just print unreachable, or you know what, let's do the following. It's instead of an unreachable, I want to see what character we get. So unexpected character, and we're gonna just have person sign C, and we're just gonna put C like this. And yeah, unexpected character. How did we get 0? Yeah, something ain't adding up, which I feel like is really sus. Okay, it did stop. The unreachable already ended, but now it goes indefinitely. So here, one thing we could do is just the following. We're gonna cut this out. We're gonna just have a while 1, or let's call it a while true. If tk.kind equals to teof or tk.kind kind equals to unknown, and we're gonna break. That's basically the idea. So let's recompile this, and it still does that, which is sus. Okay, so let's whip out the debugger one more time. TEOF. Why is it continuing? Because I would assume it would end. Okay. Skip the white space. We check if it is that. No, we peek. No, no, no. Yes, yes, yes. That is correct. We check, and here I can do the following. TK. The kind right now is an identifier. Next, 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 next. The kind, it says it's an ident, but it isn't. Okay. Why is it saying it's an identifier? The first one is an identifier. The second one is an equals. So if I run this entire thing yet again, and I quit the compilation. Okay, we're gonna have this. I'm gonna take that. We're gonna kill the compilation buffer. Yep. And so this is correct. So I would assume for it to end, but it is not ending at TEOF. So this was very stupid of me, because I should not be checking that. I should be doing the following. I should be checking the next token. You know what? Let's do the following. We're gonna just get this token, TK equals to this entire thing, and check like that, and we're gonna just have a TK, and that theoretically should fix it. Yep, and that in fact did fix it. So that was just stupid of me. I'm a bit tired. Okay, so now we got the lexer and the tokens. So the next thing we're gonna be building is just the parser. So let's get started. So I'm gonna put all of the types at the top. Type def struct parser. So what is the parser gonna be? So the parser is, I think it's the most straightforward out of everything. It's just gonna take the lexer and the current token. So it's just lexer underscore t, and we're gonna take view pointer L tk token underscore t, which is gonna be current like this. That's basically what it does, and we're gonna start parsing this entire thing. So we got this, so let's just quickly get started with this thing. Parse advance, and we're gonna be basically taking the parser p via ptr like so, which is gonna be voided, or you know what, not ptr but rather parse advance like this, and we're gonna have a parse expect. That's it. We're gonna have a parse expect, but this is obviously gonna be a boolean. So we're gonna take a parser and we're gonna expect a specific token kind. Token kind t tk. That's it. These are the most important things. And let's quickly just get started with these two functions. So the parser advance is just going to be taking in that specific lexer that we're going to be taking, and it just is going to move it with that specific token next. So what we mean is we're going to just get the current token. It's just going to be the next token for that parse specific dash lex. That's it. This is all the parse advance does. And the parse error is relatively easy as well. So this is just for us to check if we have any like error character. So we can just save this in something like p-lex-src. And we're gonna just basically log with the fprintf, which should be relatively easy. So we can just do fprintf. And parse error, it also expects the message, what we want to print out. So we're just gonna be like this. We're gonna obviously do the following. That is gonna be that, and this is just gonna be basically src. We don't even need to basically do it like that. We can just inline the whole thing. And because we can be fancy in printf or any C string in general, we can have a format specifier to indicate where we got that specific error, like so. So this is just gonna be, we're gonna cast the talk.position into an empty string. That's it. And by the way, all these have new line. Let's not forget that. Obviously. And that is basically what our parser expects. So that's the entirety of the thing. And we could obviously have a wrapper around this because this is just an error message. We can do the following, and we can just have another one with a boolean parser expect at, and this one we can call it expect. That doesn't accept the message, but rather the token kind. And if we're gonna, this is just basically what we're gonna check. If p at that current dot kind not equal to kind, we're just gonna be like const char pointer msg is we can do sprintf. Okay, so let's do the following: char buffer, which is 256, like so, and sprintf. Yeah, sprintf. We're gonna accept the buffer. We're gonna accept that specific format, which is expected percent sign s, but got s. So we don't even need quotes here, but got percent sign s. And this is just gonna be the token kind name, which is the kind, but then we got token kind name 2 as p dot current, but this has to be obviously kind. And now we just parse at that specific error. That's literally what we do. And the message is just gonna, yep, and we're just gonna return false, and we return true. We got this, so we can just now use this entirety as a parser to make the tree. So let's quickly construct nodes, and after this we're basically almost done. We're just gonna make the tree, and we're gonna be good to go. So the node is just gonna be consisting of an expression. So we're gonna have, for now, we're gonna have we can make the identifiers an atom node. The numbers are gonna be number node, and expressions like end is gonna be end, and we're gonna have binary and unary operation, but we don't have any of those, so we're just gonna keep it to unary expression for now, to at least make things simple. So let's quickly just get started with the node. Type def node struct node underscore t. Right? So this is just gonna be the basic idea. Here, one thing I probably would like to do is just type def the node, because C is a very old stinky language, and I can't have a self-referential struct like so. So to make it at least easier, let's use the following. So we're gonna have some node kinds. So let's quickly just construct some node kinds. Type def enum node underscore kind underscore t, and this is just gonna be including node not, because we can just call node atom, because that's what we're gonna be building. We're gonna have node end, which we're not gonna extend by any means. Then we're just gonna have an equal to that specific node. So should we make an equal? I think we have the luxury to make equal. So we're just gonna be node assign. I think this is basically good. So here, this also saves the node count. It's a good idea to prefix what these are, so we can have prefixing, but we could obviously clean them up later. Okay, here it is. So the idea is gonna be this node kind underscore t. We're gonna have the node specific kind, and then we're just gonna make a bunch of nodes and put them in a union. So they're like a tagged union, and we can easily switch upon them. So let's quickly just make some nodes. Type def struct unary node underscore t, which is basically the child of that specific node. And what else do we have? We can have an atom node, and an atom node is basically gonna be the thing that we're gonna assign. So that's basically it. Node child, and it's gonna have a size t of value. So here it is. That's basically it. And yeah, for now I think we have an assign, an atom. We don't even need assign anymore, because that assignment is gonna be done inside of atom itself. Yeah. So basically, for now, I'm trying to make it as simple as possible that we can. And yeah. Okay. So the node kind, and this is just gonna be a union of unary op and atom node t. It's just gonna be atom node t, atom, and unary node t union. That's it. We're not gonna be doing anything special. So now we got all of this important, glorious stuff. So we can then immediately just construct a make node function. So let's quickly just do that. node underscore t make node. Obviously this just needs to be a pointer, so then we're gonna quickly just make the node kind like so. So obviously this is gonna be what we would expect it to be. We're just gonna malloc. We can just do the following: node t pointer node, just gonna be malloc size of the reference of node. Basically this is what make node is gonna look like, and but it has to be zero initialized. So I think it's best for us to use calloc. So now we can just put 1 and that, like so. So, and we're just gonna do node kind equals to kind. Here I would like to just check if not node return null, like this. And this one we can just immediately return the null. That's basically the entirety of the make node. And now let's quickly get started on parsing the node. So we can just have node t parse atom, basically, because that's one thing what we want to do, and it's gonna take parser t as a pointer, and this is obviously going to be returning a pointer like this. So we got this parser, and what we're just gonna be doing is just we're gonna just make a node, which is obviously a null. I would like to have the definitions up front so I could see what we're gonna do. Yeah, something like this. So now we're just gonna be, by default, that kind of node is just gonna be an atom. Yeah, this is just gonna be as simple as node dash kind is just gonna, or you know what, let's do the following: node underscore t and underscore t kind equals node underscore atom. That's basically it. So now we're just gonna check if the current parser's character kind is equals to an identifier. We're gonna check. We're gonna quickly just node equals to make node, and inside of here we're just gonna make an end. That's it. And that's literally what we care about, but we want to make the name. So the atom node doesn't also need to just contain the child. It should also like contain that specific name. So I would like to just have something here to contain the name, const char pointer name, or let's put it like tag or something. Sorry, just I'm quickly like basically out of ideas. I'm really sorry. So here what we can do is just node tag is just going to be current underscore name. The current underscore name, and that's literally it. Then we just simply, and this is not end, this is atom, and we're just gonna be parse advanced. This entire thing. Then we are not gonna, we're just gonna continue with if it is an equal sign. And so Emacs is right now really having a seizure and giving me a hard time. Yeah, sorry. And if this entire thing is equal, right? If it is equal to, then we're just gonna get the current token kind, which is the operation, which is basically it is basically an assignment, but it's really easier for me to just visualize it like so. So we can just do p current kind like this, and we're just gonna check, or if not parse expect. If we don't expect a number, we're just gonna return null. That means if it is not a number, we're gonna expect null. But if the kind was node atom, we are just going to be we're just trying to make a second node, node kind, not node kind, I mean node p underscore node, and let's call it node 2, and we're just gonna make the node here. We are going to make node assign. I need assign node. Yeah. That's basically what the idea is. So let's quickly have an assignment node here, because I think it makes my life easier. Assign like this. So the atom defines the name, and the assignment defines our assignment, and that is that. So now we're just going to be iterating between the entirety of the name, and we're gonna convert it into actual numbers. So the way we do that is simple. Size t of size, obviously we're gonna start from 0, we're gonna call it num. And here let's do the following. Size ti equals less than p current name, and obviously this has to be strlen. And this is just going to be plus I. And if it is that, we're just going to do the whole num equals to num multiplied by 10 plus, we're going to size t of that entire p current dot name at that specific index minus 0, which is basically the null terminator. That's basically the idea, but this has to be obviously like scoped here. And this is not a null terminator, but rather 0. Yep. And now we're good to go. So here we can just do node 2 dash atom dot value is just gonna be number. And then we're gonna just have the atom child is just gonna be the previous node. And we're just gonna parse or advance that entire thing with p, and we're just gonna make node equals to node 2, and that's basically the idea. I think that's basically what we want, and this can obviously be an atom node. It doesn't need to be assignment, but it makes it really easy to just debug this when we make the tree. Yeah, so we have that. So after this, we're just gonna simply return the node. Return node, because we don't have anything else to do. End is an expression, so we're gonna use it to parse it in the expression node. That's it. So node t pointer parse expression. See? Parser underscore t pointer p. And so right now we only have one expression, which is end and exclamation mark. So what we're gonna do is bool negate is just gonna be false by default, obviously. So here, if p dash current kind is equal to t x exclamation. If it is an exclamation, it's gonna be negate equals to true, and we're gonna advance the parser like so. That's basically it. So now we're gonna get the left hand side of this entire node 2, or we can call it LHS. It's just gonna be since we don't have any binary expressions. Do we have binary operations? Yeah, end, because end is required a left hand side and a right hand side. So it's gonna be parse bean op. We can call it like this, bean op p. Obviously this function doesn't exist, we're gonna create it. And this is just gonna quickly return null, like so. And if it is negated, what we can do is just node t node equals to make node, and we need a not node. You see, this is node not, because we obviously negated it. Yep. And after this, we're just gonna make a node of unary. It's unary child. I called it uni. It's just gonna be the child. Just gonna be LHS, this left hand side, and the left hand side is gonna be equals to node. And that's basically it. We just simply return left hand side. Now we just parse the end expression. So we don't even need to technically parse bean op, because it's just gonna be a parse end. So I don't see ourselves doing any other binary operation outside of this. So I think we can just call it end. I feel like that. Okay. Anyway, so let's do the following. And this is just gonna be straight up simple, because yeah, should we add it? Because I'm really contemplating on it. But anyways, okay, let's ignore it. So we're just gonna have parse and yeah. Then this is just gonna take the parser at specific t pointer p, and here we're gonna just have a node p of an expression of an LHS. This is just gonna be well, we don't need anything actually. It's a parse at, and this is just gonna be at the specific t. So now here what we're gonna do is just while p dash current dot kind equals to press n, we're just gonna parse advance that specific. We're gonna advance that specific parser, and it's gonna literally be the exact same thing, but this one is just gonna be RHS. Then we're gonna check if not RHS, we're just gonna return null. And if it is not otherwise, we're just gonna make node t pointer node equals to make node, and we're just gonna make node end like so. And that's basically it. Yeah. Well, because end is a binary operation, it kinda makes sense to store a bin op. So let's do the following. Binary node, and this is just gonna be LHS, RHS, yeah, binary node, and this is just gonna be like this, something like this, yeah, something like this, and this is not gonna be uni, this is just gonna be bin op for now. Bin op, then it's gonna be LHS equals to LHS, and that's basically that. LHS equals to node, and we're simply returning LHS, literally, and we're done. The entirety of this thing is literally done. What we're just gonna do is just construct a printer and use this. It's literally over. So let's quickly just make a pretty printer, and obviously like we can clean up the code later, but that's besides the point. So we're gonna do the following. Node print node print, and this is just and here let's do the following. Bin op, or no, node print is really fine. We're gonna take the node t pointer node like so. So obviously we're gonna static assert the count of the node. So where is my node count? 0, 1, 2, 3, 4. It's just gonna be that. Static assert is node count equals to 4, and end node count exceeded. Perfect. And if it is not node, we'll obviously return from this entire thing. So now we're just gonna do a simple thing. We're just gonna switch node kind like this. That's it. And here I want to do a little bit of Emacs magic and do the following. Case yep. So now all we do is just an fprintf of this entire thing. So we can just have an atom %s like this. Obviously this is not going to be pretty printed, but we can add that later on, but this is just going to be the basic idea. And this is std out, and that is basically what we need. We can just use regular printf, honestly. I don't know, we don't even need to go that far. And this is just going to be a node tag. That's it. That is the entirety of this thing, and we are going to break. And here, this is just going to be what we're going to do for all of them. This is just going to be assign node assignment is fine. We don't need to tell if it is assigned or not, because that's going to be known by the following. Node atom dot here atom, this is just going to be name and %sign s. The value is going to be 0 as far as I'm concerned. And this is just node tag. It's just going to be node atom dot value, like this. And yeah, and a not node is just going to be that, and atom, and this is just going to be that, and it's just going to be not. If it is an end, it is just going to be an end, right? If you like it. Okay, this is just going to be an end. And we don't need any of this stuff. And this is just going to be break. And if it is a not, it's not like that. And I think that's basically it. We have a sign, we have an end, we have a not. Yeah. Okay, so let's try to recompile this, and p-lex. What did I call it? Oh, okay, you know what, let me just call it lex. Int tk. tk. Oh, this has to just be token. Wait a minute. This has to be not token kind, but rather token. Yeah, I'm a bit stupid. This has to just be kind, not tk. This is just going to be the p at current. I'm stupid a bit. This is just going to be buffer. Parser expect p comma number. Here I'm missing a semicolon. That's fine. I don't need this multiplication. Token op kind of p, that's unused variable. Yeah, that's fine. P dot current kind. This is just an equals. Parse end. Oh, parse end was never defined, so let's quickly define it up. Someplace like here. If exclamation mark node assign and node count not handle. Okay. Obviously one thing we have to do is just break, and we're gonna have case and case node count default, not the default one, but default print f unhandled, because I might want to see what ends up happening. And here we're gonna break, and here we're gonna print. We can just put char, and we can just put a new line. Yep, and we got that. So now what we ought to do from here on out is just construct la pausa. So here, this is gonna be the idea. We're gonna have l'Alexa parser t advance, or let's call it p. It's just gonna contain dot lex is equals to a reference to Alexa, and we're gonna parse advance. We're gonna just take parse AST, and we're just gonna make Z3 out of this thing. It's just gonna be parse expression and a reference to p. And we're gonna do node print 3. That's it. This is the entirety of the thing. We have an unused variable, that's fine, let's put it down. And this theoretically, okay, it kind of failed. We have an atom, but the tag was empty, and I think I know why. Where do I do tag? We create the atom, but here we have to, the tag is a const char name, and I think I have to str dupe the name. I feel like it. Okay. Alright. We make a node. Feels like I did some fucky wacky. Here, let's use this kind actually. And yeah. You don't necessarily need to make a second node, because an assignment node, yeah, even though we have an assigned node, it's kind of useless actually, because nothing is gonna be done here. Yeah. Yep. We're gonna make an atom node, and we're gonna just do that. Yeah. This is kind of what we want, and this is just gonna be 3 basically. And here we're just gonna just delete this section. It still does that. So let's quickly whip out our glorious debugger. We're gonna just run. We're gonna breakpoint at 263. We continue. We're gonna step into it. It's a parse expression. It's an exclamation mark. It isn't. We're gonna. Okay. Oh. The first thing is not an exclamation mark. So. Okay. Run yet again. Continue. Next. Next. Run. into is the current kind. No, it isn't. Step into this thing. Okay. We parse the atom. If it is an ampersand, no, we return LHS. Then, if it is not null, we continue. Is it negated? No, we return that. Okay. Then, it did not go into basically this thing, parsed atom. I would have expected you to go, because why would you not go specifically? Because it feels really suspicious that you did not go. And I think this else if is the problem. Yeah. Okay, I think I know the answer. Okay. So where did we do else if? So here we're gonna just nuke that. We're gonna just rebuild again, and boom, expected a number but got equal sign. Yep. Okay. So that's a really good. If parser equals to that, we first advance the parser. Perfect. And it's segfaulted. Why? Okay, expected number but got equal sign. Okay, yeah, because we are explicitly telling it. But we need to advance the parser. Go to the next stuff. I wonder where it fails. Is this where you fail explicitly? Yeah, okay. I'm really confused. So we're gonna rebuild this, and we're gonna just quickly step into it, and we're gonna just check it. Run, break at 264, continue, step into it, next, step into it, next. Now segfault is happening right here. Why? Why exactly? Okay, so let's watch the latest. Perfect. So now we got some expression. So can we edit this expression? And what is the value of the node tag? It is empty, and I think we know why. Okay. So we move on. Next. Here is the segfault happening. Yeah. Why specifically here? Okay. Anyways, one thing we figured out is we have to str dupe the name. Str dupe this specific name, like so. And this is where the segfault is happening. Isn't it like that? It's still segfaults here. The segfault is fine. But what am I doing wrong? We have the name's size. I'm really confused by why it's crashing here. Let's retry it again. Run, continue, step into, next, step into that, next. Okay, so what is this specific name? Can I watch it as a dereference chart? Okay, so it is. Okay. Next, we expect a number. Yes. If the node kind is Atom, I want to make an Atom node. Why exactly are you failing here? strlen. Yeah, something is not correct with the name. I feel like it. And I want to. Okay, the name is apparently null. But how? Current. It's the token. The token dot name. How is it null? How is it empty? Okay, you know what? I think this is being printf. Yeah, it's empty. Okay, we figured it out. Okay, so where do we set the current name of this specific token? We parse advance, we lex, and I feel like passing in a const char pointer means we have to duplicate it somewhere. It feels like it that way. Issue was kind of stupid. It was just our name, my pointer arithmetic was wrong. I just needed to do just that. So now after this, if we build this entire thing and it segfolds, why would it segfold yet again? It technically didn't parse it, because I would have assumed that it would. So maybe this has to be something like minus L dash post, something like that. Boom. We got it. This was basically what was missing. So the bug was kind of stupid from my end. It was, I did not account for the name in creating the number. Stupid, I know, I'm really sorry, but it is what it is. Yep. So this is what we get from this entire thing. Now obviously you could customize everything and all, so I hope y'all enjoyed, and maybe next time we're gonna use this to make something like find plus grep